Hi, this is Endo, and I will be reporting about the ocean thermal energy conversion, or commonly known as Otec. So, just like any other power plants, Otec uses the same principle in the generation of electricity, only the graphical location and the source of energy is mainly altered. So, I'll be discussing the different classification of power plants depending upon the location and this type of cycle. And finally, its applications. So first up, there are classifications of Otec power plants depending upon the location. The land-based power plant, shelf-based power plants.
Good day, sir. I'm going to report the principle or workings of Otec, or what we call the ocean thermal energy thermal conversion. The Otec is a technology which converts solar radiation absorbed by oceans to electricity energy. A renewable energy technology that uses the natural temperature difference in oceans to produce clean, reliable electricity day and night, year-round. A process or technology for producing energy by harnessing the temperature differences, or what we call the thermal gradients, between ocean surface waters and deep ocean waters. Working principle of OTEC is that it uses the warm water to heat and vaporize a liquid. The ocean's warm surface water, having a temperature of 25 degrees Celsius, is used for the OTEC to vaporize a working fluid, which has a low boiling point such as ammonia. The turbine generates from the vapor when it expands. The vapor is then cooled by the seawater that has been pumped from the deep ocean layer, where the temperature is about 5 degrees Celsius, that leads to a condensation of the working fluid back into a liquid. This is a continuous electricity generating cycle. The efficiency of the cycle is strongly determined by the temperature differential. The bigger the temperature difference, the higher of the efficiency. So this is the schematic diagram of the OTEC. Three types of OTEC power plants such as closed cycle, open cycle, hybrid cycle. So we can see the cold deep water in 1 kilometer's depth, and above it is the warm surface water, and above the warm surface water we have the OTEC. We have the evaporator, working fluid, turbine, the generator, the condenser, and the pump. So the condenser gathered 4 degrees Celsius of water going to the condenser and going back down to the pump and to the evaporator, going down to the warm surface water having a 24 degrees Celsius and going up to the evaporator again for with 27 degrees Celsius and going as working fluid going to the turbine and back to the condenser using a generator. That's all, sir. Good day, sir. I'm going to report the part of Eugene Avergonzado because he is from Bohol and has no internet connection and no electricity due to Bagyong Odette. So his part is the formulas. The formula of Otec. The thermodynamics formula. First is the Carnot efficiency. It is equals to 1 minus cold temperature over hot temperature, and second is the actual efficiency, where it is the work done over the heat supplied, and the heat supplied is equals to mcp t, and mass flow rate is equals to density multiplied by velocity. So next is the sample problem number 1. Consider an Otec system operating between 30 degrees Celsius and 5 degrees Celsius. What would be the maximum possible efficiency for an electric generating station operating with this temperature? We need to find the Carnot efficiency. To find the Carnot efficiency, we need to convert the temperature to Kelvin by adding 273 and substitute them to the Carnot efficiency formula to get the maximum possible efficiency for electric generating station, and we would get the 0.08250 or 8%. And next is the problem number 2. In problem number 2, in a closed cycle Otec power generation system, water flow rate to evaporator is equals to 1,000 tons per hour. Ocean surface temperature is equals to 25 degrees Celsius. Ocean temperature at 1,000 meters depth is equals to 5 degrees Celsius. The density of seawater is equals to 1,000 kilograms over meters cube. Specific heat of water is equals to 4,200 joules kilogram degrees Celsius. Calculate the power output of an ideal based on Carnot cycle efficiency Otec plant in such conditions. Show all the parameters on suitable diagram. Given is the water flow rate to evaporator, which is 1,000 ton per hour, converted into kilograms per second, which is 277.778 kilograms per second. The ocean surface temperature, which is at 25 degrees Celsius, converted into Kelvin to get 298 Kelvin. Ocean temperature at 1,000 meters depth, which is at 5 degrees Celsius, converted into Kelvin also, which is 278 Kelvin. And the density of seawater, which is at 1,000 kilograms meters cube. To solve for the power output, we need to solve for the rate of heat, which is Q is equals to mcp delta T. Substitute the given. Cp is equals to specific heat, which is 4,200 joules per kilogram degree Celsius, converted into 4.2 kilojoules over kilogram Kelvin, and the rate of heat is equals to 23,333.52 kilojoules per second. Next is to solve the Carnot efficiency. We need to substitute the temperatures that has been converted into Kelvin, and we would get 6.71%. And to solve for power substitute Carnot efficiency and heat supplied to actual efficiency formula, and we would get 1,565.6792 kilowatts. So the problem number 3, find the quantity of water to be pumped to Otec plant working with a surface water at 27 degrees Celsius and with cold water at 8 degrees Celsius at a depth of 600 meters from the surface to obtain 1.0 megawatts of thermal energy. Assume the density of ocean water is 1,010 kilograms per meters cube and the specific heat of water as 4,200 joules kilogram Kelvin. The given is the surface temperature converted into Kelvin, which is 300 Kelvin, cold temperature converted into Kelvin, which is 281 Kelvin. Work is equals to 1 megawatt converted into 1 1000 kilowatt specific heat at 4200 joules per kilogram or 4.2 kilojoules per kilogram Kelvin, and the density, which is 1010 kilograms per meters cube. To solve for the quantity of pump water, we need to solve the Carnot efficiency equals 1 minus T2 over T1, or which is the Tc over the Th given from the formula from the first slide. Substitute the given temperature that has been converted into Kelvin and we would get the 0.06333. Next is to solve for the heat supplied using the actual efficiency. Substitute work and Carnot's efficiency, and with efficiency we would get 15,790.3048 kilowatts heat. To solve for the mass flow rate, we need the formula for heat, which is Q O equals mCp delta T. Substitute the given and m is equals to 197.8735 kilograms per second. And to solve for the quantity of water pumped, we need to solve the velocity, and we know that m is equals to PV. Substitute mass, flow rate, and density, then we get V is equals to 705.24 kilograms per hour. That's all for Agent, sir. And that's the end of our presentation.